The universal anesthesia machine ensures that an adequate supply of oxygen and anesthesia is always available to meet patient demand, no matter what the environment. The UAM provides several ways to deliver oxygen, including connections for cylinder and pipeline. Most importantly, the machine produces its own oxygen, using an integrated concentrator that converts room air into 95% oxygen. Ambient air is made up of 78% nitrogen, 21% oxygen, and 1% other gases. The oxygen concentrator in the UAM removes nitrogen from room air, creating a mixture that is 95% oxygen and 5% other gases. Air is drawn into the UAM and is purified by 3 different filters. The compressed air passes into a canister filled with a powdered material called zeolite. Nitrogen sticks to the zeolite, while oxygen and other gases flow through it to a reservoir tank. The UAM produces up to 10 liters per minute of 95% oxygen. The oxygen then travels through the flow meter into the back bar and reservoir bag. The flow meter controls the amount of oxygen entering the back bar and available for the patient. The spinning bobbin shows the flow rate in liters per minute. The back bar serves 3 functions. First, the reservoir bag stores the oxygen. It holds up to 2 liters. Second, the pressure relief valve limits pressure in the back bar to 5 centimeters of water, protecting the patient from harm. Third, the air inlet valve allows room air to be drawn in whenever the supply of oxygen is less than the demand, as expressed by the patient's minute volume. We'll come back to this shortly. The low-resistance draw-over vaporizer adds volatile agent to the carrier gas passing through it. Volatile agent is added by using the selector wheel to achieve the desired percentage. We now have anesthetic gas comprising oxygen, volatile agent, and a variable amount of room air. The anesthetic gas flows from the back bar at low pressure to the breathing block and the bellows. A sensor reads the oxygen concentration of the gas passing to the patient. The reading is displayed on the oxygen monitor screen. As the gas flows from the oxygen sensor, it passes the first one-way valve, then the bellows chamber, followed by the second one-way valve. During spontaneous breathing, both non-return valves open for inspiration and close during expiration. The bellows are used for intermittent positive pressure ventilation, also known as IPPV, or controlled ventilation. When the bellows are raised, gas flows through the first non-return valve into the bellows. The second non-return valve remains closed. As the bellows are pushed down, the gas flows out through the second non-return valve into the inspiratory limb. The first non-return valve is closed. Another pressure relief valve ensures that excessive manual force on the bellows cannot cause harm to the patient. The UAM uses a conventional Y-piece patient connection. The anesthetic gas flows to the patient through the Y-piece, connected to a face mask, endotracheal tube, or LMA. The expiratory limb of the Y-piece channels gas to an inflating valve on the UAM that functions like an AMBU valve. It uses a balloon made from long-lasting silicone, which closes during inspiration to direct gas into the lungs. During expiration, the balloon empties and opens the exit port, allowing exhaled breath to flow out through a final one-way valve to a scavenging device. The UAM always produces the correct supply of anesthetic gas for the patient, in any environment where surgery is performed.